So thank you very much, everyone, for joining the session. The session is called Engineering for Data Science. This is, probably trapped a few of you thinking that this is going to be a technical deep dive session, but it's not. It's more of a practice style session. So how do you develop the practice? How do you develop the correct frameworks? Consideration in how you architect things, etc., etc. So before we begin, let me move the slides. They're not moving. Just hold on. Quick intro about me. So my name is Andreas Bergstedt. I work for Microsoft. So disclaimer, I have bias towards Microsoft products, and not just because I work there, but because that's where I started in the Microsoft BI stack. I am a data and analytics specialist, and I work for a team called the Global Black Belts in the EMEA division, or the EMEA organization. We're sort of a technical pre-sales team that go in and try to help customers with their either blockers or challenges or architectural support, that sort of thing. We do some escalation between the customers and program group. So if there's blocking technical issues that needs to be sorted out, we handle some of those escalations. And we build sort of proof of concepts and some other technical patterns. If you want to have a look at my GitHub, where I share some of my my code, so I have a current repo that's currently on screen. You can do so there. There are links there to different pattern designs, how to, my current thing is called the Tech Lab series, where I'll walk through different CI/CD patterns, etc., etc. If you want to join me or reach out to me on Twitter, you can do so at Andreas Bergstedt, or connect with me on LinkedIn, whichever one works for you. Right, so let's start the session. So if I've chosen a bit of an interesting background for the slide deck, because most of this is going to be about theology, or I see data architecture as a highly religious subject. There are a lot of different schools, and there's a lot of people that like to debate this and get hot under the cover. And I invite anyone to have a discussion with me around data architecture. I'm open. I listen. I try to be as neutral and agnostic as possible, and I encourage debate and discussion. So hence this Mad Max dystopian background. It's because people just want to sort of illustrate the subject we're going to talk about. So the first portion of this is going to be just around the sort of the anecdotal subject, and then we're going to walk through a couple of other talking points around how we actually engineer and create the correct environments and platforms for data science and data engineering to coexist. So let's begin. So the first thing I want to talk about is what's known as the analytics paradox, and it's not. If you go out and Google it, you won't find anything under analytics paradox. It will be the analytics adoption paradox, and this talks about when we as data architects create or envision platform, we often make mistakes. We either focus on the data itself or the technology, or just on the people, and we have to sort of see it holistically. And if you look at the trend on what's happening at the moment, that more companies than ever before have access to data and analytics, but very few of them actually manage to use them effectively, use the data and that effectively. And there's sort of a harsh reality that all large-scale transformation programs are currently happening or have happened in the past. They don't always seem to yield the correct return that they were supposed to envisage. And there's been studies around what implementation costs are and how much companies are spending, and on average, the average return on everyone's investment is about 55 cents to every dollar spent. So that's not very encouraging in moving to the cloud. And the reason for this is that there is a fundamental disconnect between the resources spent on technology and the people that are supposed to benefit from it. So as data architects, we focus on a specific area because we have a certain bias towards the technology or a data architecture, and we forget about the people. And if you can probably imagine a program that you've gone through or project that you've gone through where during the initial phase, the initial envisaging phase of the project, there was a lot of buy-in, everyone were excited, and as you start going on this project, it sort of tails off, and people either, if this was a transformational program around operational patterns with data, so you might find that moving, if this was a cloud program, right? So you're migrating from your on-prem, you'll find that the SQL DBAs, they might get a bit discouraged because I liked my SQL Server better where I had control than my PaaS environment, because I knew how to optimize my my 10 to spin faster than running in SQL, SQL DB or managed instance in Azure. All of a sudden, the only way I can solve this is by either scaling up, and it's going to cost money, and I can't manually tweak this. So you might find there's challenges, and people revert back to either old operational beliefs where they would, instead of adapting and looking at modernizing or re-engineering their approaches, they rather just take the old and let's just PTV this. We'll virtualize. We'll take our VMs in our data centers and we're just going to drop them as VMs in the cloud. Sometimes that's appropriate, but there is often that sort of stifles momentum in a project. And if you look at the lack of buy-in as the project goes along, often programs, they just lose the momentum completely or even fail entirely because there was no adoption. And I can confess here that I've been part of programs where I ended up standing. This was before I joined Microsoft, where I ended up standing on my own and wondering where everyone went. But I'm sure that we all have some story where this was sort of true. And if we want to mitigate these challenges with the adoption paradox, the most effective way to maintain momentum is that if we shift the focus from the technical building blocks or the specific silo of interest that we sort of stepped into this, and we start focusing better on building the right culture, and sort of investing in the people who are actually gonna use this stuff and look at the providing insights into how their work experience is going to be like and how much easier it's going to be for them going forward, then then at least you break down some of these culture barriers, and the people that would jump these projects, that will come with you because they feel invested in and not alienated. And this can be simple things. Training, quality training and education. Selling the benefits of becoming data centric, because that's another thing. Moving to the cloud, the idea is that we're going to become a data centric organization. So this is the segment around that I want to talk around with in terms of the analytics paradox. Next subject is walking through the burden of data architecture. And this sounds very doom and gloomy, but it is a reality. As if you're building a data platform, either as an EA or as a data architect or a solutions architect, you have this generic sort of cloud platform style framework where you have data integration, you have data science, data warehousing, perhaps, and a data lake. You might have data marketplaces, you might have API endpoints and web apps that you have, and you have BI and reporting components. When we start looking at this from a as a solutions architect or a platform architect or data architect, it is so easy to focus in on just the technical aspects. And you say, well, I like these components and they fit the criteria and everything is interoperable. But when we do that, we often fail to look at the NFRs, the enterprise non-functional business requirements like security and privacy, governance and compliance, availability and recovery, performance and scalability. We isolate that subject normally in our niche expertise field. Skills and training, huge overlook in most architecture designs. Licensing and usage and consumption, and then obviously monitoring and observation. We sort of, it's very easy to forget those, and then we go for often default patterns. So we decide that we want to have, currently there's a lot of drive-in, or there's been a lot of adoption in the sort of data lakehouse architecture. So if we look at those, they come with, there's some pros and cons to these things. So if we start looking at the actual data architectures and what those sort of implementations look like, they have their pros and cons, especially around the NFRs. They're data lake analytics and lakehouse architecture patterns. They are awesome when it comes to availability and recovery, and from a consumption perspective and licensing, because it's mainly open source products. They're cheap, readily available. You can choose whatever compute you want, and it's great. Great support from a data science perspective. It makes it easy for data science to work. Challenging somehow, or quite often challenging for the data warehouse crowd and the sort of enterprise, business enterprise reporting spectrum. And there are some integration challenges later on with the reporting layers as well. But generally, data lake and lakehouse patterns and data lake analytics is great for licensing and availability and recovery, because you can build them cheap and they're available. Often complexity with skills and training, because there's just so many moving components within these things, right? Then another big trap that we've seen lately is around not necessarily a data architecture, but more of a business framework for data. So data mesh tries to solve all of these NFRs by not making them relevant, by saying that each data mesh is more of a business unit or a business domain. Each business domain have their own environment. So data mesh is trying to decentralize and decouple everything, and it's this business unit's problem to deal with the various NFRs. And this is some real big challenges around governance and compliance, and also security and privacy, because you're effectively spinning up an environment per business domain within your business. So there are some issues there. The other issue is with performance. Generally, performance is a big problem, because you can't. it's hard to if you take the data mesh purist approach, you should be virtualizing all these environments. Should just be virtualized representations of your existing environment, but that means that there's compute bottlenecks and data transient bottlenecks and some big challenges there with scalability. Also, from a consumption perspective, you ultimately end up moving data or copying data between environments or between business domains. So if you have various data mesh versions of your data warehouse, so you've got 3 different environments for 3 different, marketing, finance, and I don't know, third one, human resources. So they all have their own environments. They siphon out, you end up duplicating the data across those 3. And it just, there's general consumption challenges there. Then let's also quickly just go through the last one. And this is something that it's not necessarily a data pattern, but it's more of a data solution. So data cloud, there are 2 main vendors in the market for this. The one is Snowflake, and the other one is Palantir. And data cloud is not a data platform per se. It's more of a data as software as a service solution. So you will not host. You don't have to architect anything. And this is it's awesome from an architecture perspective, because you don't care about the architecture. You care about, the only thing you care about is where your source data is coming and what your data models are going to look like. You don't have to worry about choosing the right compute or the scalability, because that's just something that is a problem of the provider or the vendor. And all the tools or all your code is natively in this environment, so it just makes it easy to get in there very quickly. The challenges though comes, and there are big red flags around these things. And I'm going to try not to mention vendor names when I say this, but if you take the one main vendor, I guess, that's out there, that coined the original vendor that coined the phrase data cloud. If you take their stance, they say the data warehouse or the compute is forever scalable. You don't have any bottlenecks, and you don't need to index anything because you can just scale your clusters. So that solves your performance issues. That comes at a big price. So effectively, you double your cost every time you scale out, because that's just how it works. The other thing is there are hidden costs. So the ease of administration. So a lot of CIOs and sort of CDOs, they like these concepts where they don't have to worry about the DBA skilling on the technology, because you should never, you don't have to, performance or troubleshooting here is a tick box where you say, I want to optimize all my tables. You tick a box, and in the background the vendor is optimizing your table structures. What they're doing is they're just refactoring everything over and over again. They fail to mention that this is going to cost you extra, and that it's normally in the beginning when they sell you these concepts, they tell you that as long as it's under 10%, and that's sort of what these 2 major vendors are generally saying, as long as it's under 10% of your total compute cost, then it's included, and we don't care about it. But you normally go over there, or everyone does. Right. So that is that sort of ends up the section around the different burdens around data architecture, and I want to round it off with what we call the analytics continuum, and this is like how we break down the walls of the data ideology by recognizing that your data is not either a fixed architecture or set in a specific technology, you should be able to, put everything into compartmentalize everything and put it into the broad blocks, and then provide data, for instance, data as variety. So we want to support, you want to be able to support the analytics continuum with all your data, your IoT sources, your apps and operational data. You want to support your SaaS data flows and your files. So you want to make sure you have one container with that, or big facilitation for that. You want to ensure that in the continuum you support machine learning, big data, data warehousing, exploratory concepts, and also BI facilities. You want to also make sure that you support multiple data models, and you shouldn't really care if as an architect what the data model is. You should encourage the data engineers within the organization to choose the correct data model for their architecture. So for their data architecture, be it Data Vault, Kimball, whatever it may be, or if you choose to not do that and rather work with flattened structures. It all depends on you shouldn't really lock anyone in. And then it's some of the biggest things of breaking down these walls is also being able to wrap this into one governance system, so that you don't confuse the various people within your that are going to consume your platform by having either complex integrations or complex requirements between between data and compute, etc. You want to try to wrap this into a straightforward framework that caters for your security and privacy, your governance and compliance, and all of that. You want to ensure that your identity management is throughout the same, so you don't have multiple ways of handling it. And then obviously I've got the DevOps Continuum cycle there as well, understanding that part of this is of the Continuum is understanding that everything falls part of it, including how you operate and develop. Cool. So then let's step forward a little bit and let's walk through the engineering for data science. So the reason the main thing I want to touch on here is that when we look at enterprise data statuses, if we look at historically, there's always been the two schools. You have data lake and data warehouse. You had data science or business analytics. There was either one or the other. And the truth is, and this is what Jen was saying in the previous slide or in the previous session in this room, was that big data doesn't exist anymore or is becoming less relevant because there's just data, and I agree with that. And this is the convergence we're seeing, is that we're moving away from it's either or, it's blending together. And in order for us to sort of hit this balance, we need to come up with a concept as a business that serves everyone. And that concept is broadly known as the data-driven enterprise, right? And if we look at the sort of the traits and the capabilities of the data-driven enterprise, there are 6 distinct pillars. The first fundamental pillar is the whole thing around single accountability for data. So you have a single architectural foundation, and we'll walk through some of those just now, where you've defined the broad framework for the data enterprise or data within the enterprise. You have analytics agility, So you're able to provision the right data sets quickly. You adopted pattern or operational frameworks like DataOps, etc., where you pipeline your data sets out. You've got the right analytic services, and not only locked yourself into specific services, you prescribe to multiple, be it either open source technologies and proprietary technologies, right? Then the next pillar is data governance. So the data-driven enterprise understands that it needs to invest in data governance. You want to be able to auto-discover your data sets in your catalog. You want to be able to classify them. You want to enable your data citizens to be able to basically do shopping cart exercise, so be able to find data assets within your entire data landscape. The fourth pillar of the data-driven enterprise is data exchanges. So you want to be able to subscribe to trusted repositories. So if you have data augmentation requirements, like you need weather data, or you need financial data sets, or whatever they might be, marketing trends, you want to be able to shop for those, so to speak. And also you want to be able to have easy access for those to be reused through your organization. And also you might have a requirement or part of this data exchange pillar, the data-driven enterprise, is also to be able to intra and sort of extra organization be able to exchange that data. So you might want to sell it on for business use, etc., where appropriate. And also, fifth pillar is the foundation for AI, and quite rightly, like Jen said also, there's a fundamental difference between artificial intelligence and machine learning. They come from the same family, but there are fundamental differences. So you want to be able to have this convergence of DataOps and MLOps together. They both are rely on each other for this continuous data continuum feed. You want to the data-driven enterprise also is able to work with provide analytics and AI concepts and machine learning concept into the operational business processes, and that's fundamental for unlocking and removing dark data within your data estate, and also enabling reinforcement learning and those kind of concepts. And then the last pillar in the sort of data-driven enterprise is the integrating collaborative environment. So you have you've got operational frameworks in place that support working across a wide range of teams and geographies. You're able to proactively monitor and manage all your pipelines, be that your infrastructure, your data pipelines, your machine learning pipelines, all of that. And you're able to collaborate between the different teams and your strategic objectives. So this is like one of those, if you think about how you engineer for data science, this is pretty much it. You sort of walk towards this data-driven enterprise. So I have a slide now that is for a subject called adopting DevOps and adapting to XOps. So Gartner released one of these top 10 trends that CIOs and CDOs are looking at in 2021. And one of the top 10 trends was the adoption of XOps. So everyone that's on this call and is watching this must have heard of DevOps. So DevOps is development as an operational practice. Sort of enables the ability to collaboratively and iteratively, continuously develop, deploy, tests, and there is a trend currently that we're starting to move towards a sort of the convergence of these all these frameworks. So what we have, traditional DevOps have some challenges, and there are different ops models and different flavors for different style of operational frameworks. The one, everyone's heard of DevOps, but then you get DataOps, Data SecOps, SecOps, AIOps, BizOps, Marketing Ops. There's anything under the sun. And all of these, if you take them individually and you look at them and you try to implement them all separately, you get into this rut where not all of them have the same workload requirements. They don't share the same requirement on infra. They don't share the same requirement on security and governance. They have different skilling requirements. They have different ways of looking at versioning. They have different ways of continuous integration and continuous deployment. There's different ways. They have different ways of doing their testing frameworks. Their how they integrate and how they do load and stress testing. They don't. BizOps doesn't necessarily care about stress testing. They subscribe to service with a business application and just pushes out and runs. There are some of these challenges with adopting DevOps as a broad pattern to each and every one, and then taking each school and then deploying them individually. So this is where the value of, or the value proposition of XOps come into play. So I say, like the headline says on this slide, adopting DevOps, because generally the generic DevOps framework is a good practice. And then adapting towards the XOps. So it's like I said, it's for this year one of the top trends, and the value proposition is around, you get standardized definitions of your operational framework. So everyone works within the same definitions and common terminology. We also, the framework also have a value proposition around common environment management. So how do you manage, your development, your integration, your pre-prod, your testing, your UAT, and then your production. There's one of the main drivers, and this links back together to the beginning of the slides when we talked about the analytics adoption paradox. Shared business culture. So having a universal framework for your operational patterns gives you the ability to have a shared vision, to have a shared business goal. Even though you might work with different technologies and tool sets, you still have the same shared business goals. You got the same shared definitions, and this is the last pillar in the previous slide, right? We look at how we integrate and communicate, and then also a final value proposition of the XOps patterns is cross-business knowledge. So the ability to cross-pollinate your IP and your insights, being able to communicate to the DataOps teams or the data teams, because now you're the same XOps organization, that there was some challenge in versioning or the data version X, from when we ran our model training, etc. So that is, what I want to say about the XOps pattern. It's not something that's common practice or considered best practice. It is sort of currently in its hype state, but it is a concept that I believe in the future, and according to Gartner, and they seem to always get these concepts right, or often get these concepts right, is that's something they see as value going forward. But currently there's XOps is not something that you can implement with a big bang approach. Right, then I have what the last slide is. I want to just talk a little bit, and this is the slice in the cake is just a term for this to illustrate this slide, and what I want to convey: when you engineer a data platform, if you look at if you often look at the finished product, so let's say that you have a cake that's your finished platform. You never start designing the cake in its finished state. You might think about where you want to go, but each layer of the cake has a different sort of reason for living or reason for it being there. So if you can define all of these slices in a model instead of just saying this is my data platform, and then for each slice you take the hub and spoke model. So you think about you have a storage layer. Centrally, we want to keep we have a data lake as a storage methodology. It's a VNA record or VNA compliant storage model, where vendors shouldn't really matter, and then you can spoke out to multiple storage accounts, and that at least then you have that concept. So if you take the hub and spoke icon, you've tilted flat, you're able to layer these on top. Same thing with data models. You should be able to, in your data architecture, you should be able to facilitate different data model layouts, and this is including machine learning models. There shouldn't be a difference between what models you can support, be there Onyx class models, be it actual data warehouse models or data set models, doesn't matter. And also compute. Look for, when you think of the compute, you should not think of a single silo. You should have this, if you have a central compute, that's fine, but you should be able to spread it out. It's like a hub and spoke with either multiple distributions of your compute or multiple compute types. But you shouldn't lock yourself into one proprietary technology. You should try to keep it open source or proprietary. And then obviously the same thing from the consumption layer. If you want to build an API layer on top of your compute and your data models, then that shouldn't be a problem. Cool. I think I am ending now, and I want to go into Q&A. Ray, do you know if there's any questions at this point?
Let me look at the chat. Let's see here. Yes. Oh, not for you. They talked about the raffle. I do see one. You said Snowflake, and what was the other one?
The other one is Palantir.
Palantir. Okay.
Yep. Right.
If anyone else has any questions, please just type them in the chat.
Okay.
I see. Do you have the chat up on your screen?
Yes,
Andreas? I do. Well, you can see that people are giving you thanks for a great presentation.
Right. Cool. Excellent. Right. In your case, can this be multi-cloud? Oh yeah. Well, so here we go. So Victor is talking about if you architect this. So yes, of course. The big challenge with multi-cloud, well, if we take vendor out of it, each and every enterprise customer that I speak to, they all have a multi-cloud strategy. They all recognize the multi-cloud as being a requirement. They all also recognize that it's going to be hybrid. We might have things that are going to live on premise in our data centers, and yes, from a compute perspective, as long as you have one of the biggest challenges with multi-cloud is that data proximity to your compute always becomes a bit of a challenge. Or you might have if you go for a specific compute technology. So one of these vendors, let me talk about them. So Snowflake, for instance, they say they're a multi-cloud vendor. The truth is no, they don't have a multi-cloud capability It's not like you buy their platform, and whether you host it on Azure or on AWS or on GCP, it doesn't really matter, because ultimately you're locked into that specific tenant. So you will be on Azure. That same goes for their data marketplace approach as well. So if you want to data share with your customers and invite them in, then you can only do that with someone on that specific cloud tenant, or else there's going to be data synchronization happening. So and the same with Microsoft platforms. We're trying to simplify this with Arc. With Azure Arc, to provide just a framework for the architecture itself, and then you should be able to deploy this on-premise or at a different cloud. It shouldn't really matter where you want to put it. So definitely multi-cloud is something that you should consider. Just understand that there's a general engineering requirement to get it running correctly. That is going to require additional thinking. Right, I see another question. Yeah, thanks for the verbalization. Yeah, best one I've seen so far, professionally. Right, great, thank you.
Hannah has one. Have you gotten down to that one yet?
No, I'm about to read it. So, based on your experience, when building a data solution for a customer, how many final objectives is the suggested advice based on your experience? Well, that depends. That depends on the requirement. When you talk about objectives, so Hannah, if you're still there, I'd like to maybe have a conversation around this, because projects, right? There you go. How many projects per customer? Deploying a data architecture. So this is complex. One project, you could have multiple overlapping projects depending on the use cases you want to put together. So if your use cases, you should be able to run multiple use cases on top of a platform concurrently. So they shouldn't. The more you pull together, obviously, the more complexity and to manage them. So from a data platform, as long as the foundation is, if you build a data architecture, you should be able to take on multiple use cases at the same time and let them run independently. As long as the foundation is sound and you're not locking in the use cases into certain tech that's going to require re-architecture later. And I think that's what I want to say around planning for the architecture, is that you should, just because today the hype word is Spark or today the hype word is Hadoop, tomorrow it will be something else. And I'm sure, I mean, yes, I work for Microsoft. Yes, I have bias towards Azure. Yes, of course. But I think there's a clear investment that Microsoft set out when they started with Synapse Analytics a couple of years or 3 years ago, when building a multi-compute environment, because it will look differently in 2 years to come. There will be additional compute engines. There will be something else that's more important. Time series data might be more important in 3 years' time. Who knows? And you can't run SQL time series queries. It's not a good engine, right? So it all depends. Right. Let's see. Punet. Hopefully I didn't butcher that name. Do you recommend platform independent MLOps? That is yes. I do recommend Azure MLOps. Or Azure ML or AML, but it all depends on your data science team. So if you like to work with platform agnostic models, then you might want to go down the AKS route or the Kubernetes route and rather work with Kubernetes images and deploy your models and train them that way. It gives you a bit of flexibility. I know some of my AI team members won't be happy with that statement because they don't get recognized for Kubernetes clusters from a sales arm perspective. But MLOps is great. It's integrated, and especially if you're going down the AML is great because if you're going down the signups route, you can natively call your scoring models. You can productionize it quite easily inside of signups. So you can let your SQL community, just be able to use your scoring models directly in native SQL code. So that's, it all depends on the objectives. Cool. Let's see. I'm not going to be able to pronounce that name because I don't read Cyrillic. Architecture and approach to logical data layers like ODS and ODD. So I am if this is challenging.
So how do you pronounce your name? I've enabled your microphone if you want to turn it on. Or not.
Or not. Right. So does the sort of, okay, so does the approach of an open architecture of a well-defined architecture support operational data stores? Yeah, sure. I mean, these are these are concepts that are common in business. Just because it all depends. Operational data stores they all depend on depends on what the consumption needs to be. And where you place them. So, for instance, if you need to have a perpetual version of an operational data store from your source applications, then you store that maybe in the lake, and you persist it there in a conformed layer forever and a day. So you can do that. Not saying that that's the best approach because you might. It all depends on what you need to do out of it afterwards. If your ODS layer needs to be transactional, then you might want to virtualize that into a compute environment somewhere. You might want to. It might be sufficient to have it in the lake and run serverless on top of that. But yeah, ODS is it could be part of your analytical frameworks and your platform. It all depends on what the requirement is. And again, multiple marts, so you might have multiple data models serving different data marts. So that makes sense. There's no real need not to have them in there, and you should support them. If your data modeling framework, if you've got, depending on what it is, you might want to have multiple marts, and that should all be supported as part of the data architecture. Cool.
Oh, someone gave us a pronunciation.
Cool. Excellent. Right. Jakob. Right. Cool. Right.
Cool. I think if there are any other questions, please type them into the chat. Otherwise, we'll thank Andreas for this. It was very, very enlightening and very entertaining.
I'm glad.
Yeah.
As a final word before we close, I'm going to go over to the data engineering room in the voice chat. So if you want to have a quick conversation there, and maybe have an open dialogue, then join me there in the Discord.
Right. Thank you.
Thank you very much.